The second interface, which is nothing but list. What is the basic properties of list interface? List is an ordered collection. Allows duplicates or not? List allows duplicates as well. Then what are the implemented classes? The list interface will be implemented by two classes. One is nothing but ArrayList, and one more is a linked list. Again, why we need to? What is the difference from this pointer to this ArrayList and also linked list? What's the difference? Every collection class will implement the mandatory interfaces. What are those? Every collection class implements two interfaces. One for duplicate copy, one for transporting the data. Serializable and clonable. Implements serializable interface and also clonable interface. Yeah. Next, along with these two, I mean, even for this collection class also, these two are applicable. That is serializer and serializable and also clonable. Then in this array list, the internal data structure support. The internal data structure support for this array list is nothing but random access. Random access is one more interface which supports ArrayList internally. Yeah. Can we perform index-based operations or not? Can we get some second index position element if it is there? Yes. Can we remove first index position element? Again, can we go back to last index position element? Again, can we come back to 0th index position element? It means we are accessing the elements in a random order. Can one time 0, one time last, again somewhere in the middle, somewhere in the starting second. So in this way, to move from everywhere in the array list, then there is a support is required. That support is provided by the random access as a internal data structure support for this. One more point here I am adding. This random access interface is a marker interface. What is marker interface? Second, behind guide. What is marker interface? So it is an interface with no methods. An interface with no methods. An empty interface. Okay. Again, I don't go that much in detail. This is the point to remember this. Then the random, sorry, for this linked list, the internal data structure support is nothing but, anybody aware of this? Doubly linked list. The order is preserved here. In array list, the order is preserved. Yes or no? What is this list here? So order is preserved. Yes, which order? Insertion order is preserved. Next, when it comes to linked list also, it is also insertion order only. Then why we need to when the properties are same? One thing is we can easily understand here one support is there, here another support is there. That is one difference. Then the order is same. The situation is here. when it comes to array list, the preference or when we should go for this array list is nothing but if the frequent operations are, so this is not as a difference here. So if frequent operations are accessing the elements of the collection, accessing elements of the collection, then the best suited list is array list, but not for adding elements, not preferable. It's also possible, but not preferable for adding the elements, adding and removing elements. We'll discuss why. Then when it comes to linked list, here there is a solution and there is a problem. Then the same thing here also. When we should go for linked list? In this array list, what's the problem? Adding and removing is the problem. Then the same thing is a solution in linked list. Then in this array list, what's the solution? Accessing elements. Same thing is a problem in linked list. That's the reason. So this is linked list is preferred if frequent operations are add or modify or remove words. Adding or modifying or removing the elements. But not preferable for accessing the elements. We can do both. Please understand this point clearly. So by using array list also we can access the elements and also we can modify. By using linked list also we can access the elements and also we can modify. But whichever is not preferred, if you are performing such type of operation, then the execution time is too delayed. If you try to modify today by using array list, it will happen after 10 years. That much difference is there. If the number of elements are something in lakhs or crores. At a country level, if you just imagine one application based on array list, we have to delete the second position element. One person passed away, so his Aadhaar number you have to delete. For example, then what has to happen? The entire array list of 1 crore elements has to be modified. That's the reason this is very least preferred when it comes to adding or removing the elements. And the same thing with linked list also. It is easy to modify by using linked list, but if you are trying to access 1/4 element, for example, then that also will give the after 10 years you'll get the result of out. You execute your program today, and after 10 years you'll get the out. That's the problem because of these two. What is it internally? You'll understand in details. Any questions? Any questions here? No? Hope you have taken. Next one, how do we create the object for linked list as generic type? Then how do we add the elements? Once we create, what will happen? And internally, how can we add extra elements? So for that, let us understand details about the array list. It's an interface or class? Array list is an implemented class. Okay, it's a class. So to create the object, assume I'm writing inside a main method, array list with A and L capital and generic type. Let us understand one integer example. Say integer and some AL is the object variable name equals to new array list. Again the generic type integer, then default constructor semicolon. So this is the syntax of creating the empty array list object. Yeah. Since we have to perform the corresponding index based operations are supported or not? It's supported in the list. It can be array list and also linked list as well. Then whenever we are performing this index based operations, we should know the index numbers. Correct or not? So by default, what is index number for any kind of arrays? For arrays, it's a 0. Even for array list also, it's starting with 0 only. Most of the any of the programming languages, when it comes to this collection type, the index points will be starting from 0. So internally, whenever as the programmer we create this empty array list object, by default, there is a size of 10 elements will be created. I mean 10 empty cells will be created. Starting index from 0, ending index is 9. So this is nothing but a 10 empty cells will be created with the help of the syntax, whatever we have done. This is the default nature of the array list. Then as a programmer, by using this array list object AL, how to add method, and you can add some elements like 10 and 20, AL dot add of 20 and AL dot add of 30. Like this, I am trying to add some elements like 10. It means last will be 100 is the value. Then where they will be stored? In the same order, because array list preserves the insertion order. So first 10, then next followed by 20, 30, 40, 50, 60 and so on. Up to last 100 will be stored. Then as a programmer, I am trying to add one more element called AL dot add of some 110. This is my next element, 11th element. What will happen? Collections are growable in nature or not? Depends on the requirement, collections will grow. Then therefore, because program is trying to add 11th element, is there any extra space available? No, there is no cell is available to store a next value called as 110. Then what has to happen? Somewhere we face this kind of situation in basic classes. Where is that? String builder. Right? What is the concept which has to happen? How string builder will increase the size? Based on some, what is that growth factor we call it as? So what is the growth factor? So it is not same as string builder. So it is nothing but current capacity. Current capacity into 3 by 2, then plus 1. What's the current capacity? 10. 10 into 3 by 2. How much? 2, 5, 10, 5 and 3, 15 plus 1. How much? 16. Therefore, the new array list will be created with how many cells? The new object will be created and this will contain the 16 cells starting from 0 to 15. And what's the previous data? 10, 20, 30, 40 and so on. Up to 100 will be as it is, it will be copied. And now the whatever is object variable AL, previously it is pointing to this object. Now the same connection will be given to the new object. Previous connection will be destroyed or removed. Then garbage collector will come and clean this object. Now this is of no use. That's why garbage collector will clean this one. Now AL will be pointing to this newly created array list object. With the help of this growth factor, please remember this. Write this one. What will be next size? For example, if you are adding 16 elements, 17 elements to be added, what will happen? All of you. What's the current capacity? Current capacity 16. What's the formula? 3 by 2 plus 1. How much? This is the, again I am writing just growth factor. This is the next one. 2 into 8, 16 times. 8 into 3, 24 plus 1, 25. Tell me the next one. What's next growth factor? What will happen here? 25 into 3 by 2 plus 1. Tell me the answer. Time up, it's 37. Yeah. What operator we are using? Forward slash. It is what kind of division? Modulo. Integer kind of division. It takes the only quotient. Then 2 12s 24. 12 into 3 is 36. 36 plus 1, 37. That's the resize. Just remove this point. Yeah. Because the array list size is growing from one size to another size, this support is given by one more interface which will be implemented by array list and also linked list, which is called as resizable interface or growable interface. Resizable or growable is a support which is getting to this array list and also linked list, because once the space is not sufficient, then the size is regrowing. That's the reason the name also it's easy to remember. It's resizable or global interface support. Because of that only it will happen. Yeah. To perform the index based operations by using ArrayList object, we can print 0th index number, we can print last index number, we can modify third index position element. So these operations are possible. Yeah. But what is the concern with ArrayList, or what's the problem? Adding one element. Then what will happen when we try to add one element at a particular index position? Okay. So that is a concern with ArrayList, which is not at all recommended, but it is possible. You'll understand that with one more next example. Where is this? For example, this is one existing ArrayList of some 10 elements, 0, 1, and so on up to 9. One AL object is pointing to this location, and this consists of some data like 10, 20, 30, 40, and so on up to 100. Then as a programmer, we have some requirement of adding one element at first index position. Adding one element at first index position is possible. Index based operations are possible on ArrayList. Then whenever we are trying to add this one element at index position 1, what has to happen? For example, 200 is the element I want to add at first index position. So because of this operation of adding this element at first index position, internally what will happen is in 0th position no disturbance. So therefore 10 will be as it is. Because programmer is trying to modify add one element at index position 1, then whatever we are trying to add, that will be added into index position 1. This is 0 and this is 1 position. What about this 20? It will be removed or it will be there. So when we are adding some more extra data, previous data should be removed or it also should be there. It also should be there. Then what will happen is this 20 will move to next index position, and then 30 will move to third index position. Like this, how many elements has to move? All these previous 8 or 9 elements has to move. Assume this is a collection of some 1 crore elements, and we are trying to add one element at first index position. What has to happen? All these remaining, whatever something is less than 1 crore, all has to shift by one cell to the right. Then that operation when has to complete. That's the reason I said 10 years. So this is the drawback. Understood? Especially as at the starting point only when we are trying to add. At last, if I try to add, will there be any problem? No. So in that situation, no problem. Happily, this last index is empty. If not, it will be regrow and the element can be added at the 1 index. There is no problem there. But if you are trying to add it in initial positions and have huge collection of data like 1 crore objects, then there is a biggest problem of ArrayList of shifting operations has to happen. That's the concern where it is not recommended to go for the adding elements at the starting index positions for ArrayList, especially starting index. Clear? Am I clear? Yeah. And who has to perform this growth factor? Programmer or internally? Internally, JVM will perform. As a programmer, we don't need to bother. Yeah, linked list I'll discuss. So it's too much of theory today. We'll go for a program. So I'm using this collections demo inside this SRC collection example. Tree set, two packages are there. I'll go for a new package of list demo. List demo, list interface demo, I mean. Inside this package, first let us understand the first example of array list demo. I'll take main method, click on